This is a Powermat charging pad. I picked it up, I think probably about a year ago from Amazon. I spotted this and a couple of related products, incredibly cheap. I think this was less than £10 for a charging mat for 3 devices. And I bought them when I spotted them at that price, just thought it might be worth playing around with. I didn't do anything with them at the time. I bought this mat and an adapter. This is a charging kind of pad which attaches to it and then plugs into a device, and it came with a little load of USB adapters to convert from the mini USB into other kind of mobile phone connectors and micro USB here. But to be honest, if you're going to have this and plug this into a mobile phone, then you may as well just have a kind of regular charging lead. It's kind of pointless. The thought was I might be able to integrate this into something at some stage, but that really never happened. It's still an interesting bit of kit. It's Powermat. It seems to be one of the kind of competing standards. QI or Key or Chai, or I'm not quite sure how it's pronounced, but it's QI seems to be the one that's leading, at least from what I can see, and that's been integrated into a number of mobile devices. The kind of latest Nexus device has got this standard built into it, and so it is kind of fully integrated. And there are a lot of other phones, you're just using a single charging mat, you can rest it down. These two standards are incompatible with each other, and they have some interesting technology in them to kind of get that to work, although there does seem to be something going on which is triggering something or another. Might not be too healthy for the device. It is powered up, and I put this charging pad, you can hear the status sound. And so that's activating charging for that pad. Light in the front. The other quite nice feature about this technology, I think it's fairly standard to the Powermat stuff, is it uses a magnet to try and guide the kind of connection point. So it, as you place the device down, it draws it into the middle. The active range of this, it's really quite small. It has to be exactly positioned, and perhaps that's why they did go for the magnet, to really encourage that. The range, as distance-wise, is also incredibly limited. We're talking about a millimetre or two, enough for the plastic case that this originally came in. So it's not very kind of tolerant to alignment issues. But I started looking at this recently because I thought it might be fun to include, try and get wireless charging for an Xbox controller. And so I having a think about this during the day, and then when I went home to have a look at it, and so I thought if that kind of sits down flat, you could potentially integrate something into the battery pack, so that when that touched down, it made contact. That's kind of all good and well, but sadly the new Xbox One controller doesn't have this. It's got a much nicer, much better integrated pad, and so if you look at the flash, there's no way that would work in there, unfortunately. So that kind of scrapped that plan. But I thought while I had this around, I'd kind of dismantle it and take a look. So I did briefly kind of start to look at this the other week when I was playing around with this idea, and but I didn't really have time to kind of properly delve into it. The screws are hidden underneath the kind of rubber mat, and that kind of pulls off, and you then get a lot of screws all around. So I'm going to remove these. So there we are, cover's removed. So there's a single PCB in here, or long-running PCB. It has a USB output on the back as well, so it powers up via this kind of input here. It's only kind of 5 volts, half an amp, so it's not going to do a particularly good job at charging a lot of devices. But then when that, so when that's charged up, you can then plug in another device in the back. So the idea being this kind of like a central charging hub. And that's slightly odd. Appears to be a bit of a spark in there when I plug that in. I don't know if that got captured on camera. perhaps not. I guess there's probably a fair bit of, quite a lot of capacitance on here that it's going to be charging up, which might have caused that. I started to kind of try and identify some of these audio, or these chips in here, and it appears to kind of broken into 3 chunks. So each charging pad is very unique and has its own kind of range of circuitry. And then there's also another microcontroller on top of that to control all 3, including these switches on here, which control the light levels and sound levels. So you can toggle between off, low, high volume levels, and also the lights as well. So you can choose between really bright, kind of dim, or off when a device goes in place. So it's a little overkill, possibly, I think, in terms of its options. And then finally down here, this is a kind of a sound IC, a sound kind of controller chip. It's got a little built-in amplifier, and you can load in a couple of sound files, and you can trigger them by touching the right pin. I was able to get it to play one of the sound files the day when I was testing this. I might be able to do it again. So if you short out the right kind of pin combination here, it was correctly playing the sound. I'll have a proper look at that later. So I'm going to unscrew this board and take it out and see what's going on with the actual charging pads underneath. Okay, so I've removed the screws, but there's I need to unsolder, I think, these terminals in here. The pad circuitry connects to these kind of wires which loop over, and that's on both ends, but there's nothing for this middle one here. And I believe it is connected through using these pins on the board, so I'm going to have to unsolder those now. So the board's out, it folds back with just those 2 terminals left, and this other pad under here, or this covering, so it's plastic covering kind of insulating a metal plate. There's clearly something on the other side of this, so I'm going to try and pop these out now. There we go, just lift it out. These seem very similar to the other side here, same kind of track on PCB. Okay, both halves are magnetic. They stick so well together. This actual pad here is very thin. You can really feel that quite loosely in this. They're trying to minimise that distance as much as possible. I expect that'll be like a millimetre or less in there. And so these things definitely have to be close to work. Let's see if I can power this up. See what range we get. So obviously this middle one is now disconnected and is not going to work. The side ones might. For some reason this isn't activating. Doesn't seem to be activating. Now, I think these should be independent, so I wouldn't expect the disconnection of this one to feed back into the other. It's possible something's been damaged here that's causing this to fail. It's quite unusual. But otherwise, these boards themselves just appear to be copper, or just a PCB trace. There doesn't look like there's any other electronics going on down here. Look like they're probably glued into place here. Don't know if I'll be able to remove it without damaging it too much. So it's just a sticky pad. The other side, there's a, appears to be just a PCB trace, little disc magnet in the middle, and just stuck in. Let's see if it's possible to reconnect this. See if that does solve the powering up issues. No sound of anything there. A little unusual. Either way, it's take a look at some of the parts on this board. We've got that focuses there. I think that's a Freescale logo. And from what I can remember looking at previously, this is just a little kind of bog standard microcontroller. A fairly kind of generic type. There's nothing real special going on there. It's just to kind of control the switching. Because what also happens on what's on this device here, these are all ID'd. So when it starts charging, the power flows from here to the secondary device. But before that happens, the secondary device reports back and tells the main controller what it is. So it feeds back to say, okay, this is a small device. You're safe to power up, only deliver a maximum of like 300-400 milliamps, and don't go any higher than that. This means that other devices can be placed onto these and nothing happens, because the phone, in this case this QI device, isn't communicating back to here to tell it to turn on, and so these pads are very safe to use for other things because they just won't turn on until this device is correctly communicated back. It's a nice safety feature, but it also does present some potential issues in creating kind of compatible, interoperable devices. I don't know how copyable that technology is and whether it will be easy enough to duplicate or clone the type of kind of signal that's needed to turn these things on. So there's these microcontrollers in here. There's the required circuitry for the kind of controlling the actual kind of wireless power transmission. We've got the audible kind of audio out chip there, and so there's 4 microcontrollers on here, but only 3 pads. So one of these microcontrollers will be for the kind of setting these settings here. So I'm just going to have a play around and see if I can get this charging again. I've identified what was stopping it from working, and it's an additional kind of sensor on the top PCB. It needs to kind of know when there's something attached in order to start working, presumably to save power, so it's not constantly trying to communicate wirelessly with whatever it's connected to. It's a Hall sensor. So if at the moment it's plugged in, it's charging, and I've got this plugged into the phone. If I separate these 2 boards, so it's stopped charging now, but if I take this lovely piece of magnetic bacon here and hold it up to the PCB, it started charging again. So up close, I'll remove that board. There's a Hall sensor here, here, and here, right in the centre of each pad, and so it uses the kind of the magnet being brought close to know to really start working. So yeah, it's clearly it's just one of the checks it does to start going. So it might kind of turn on the wireless kind of communications and then get ready to start communicating. Obviously that then doesn't communicate back to say that it needs power. So that's an interesting thing. So it means it'd be pretty hard to modify this into something else. Originally, when I first started dismantling this, it looked like it could be quite cool. These are kind of little separate pads, so you could separate these and move them somewhere else. So it's not as straightforward as that. You'd need to interface with this chip and either, or the Hall sensor, and either bypass it, assuming it doesn't have adverse power effects, or extend it out somewhere. Just going to take a quick look at this audio chip here before I close it up. The part in question, I don't think I'm going to be able to get close enough here. It's an A+ device. Focus there. I think it's a P8910A. Data sheet for that is kind of readily available. It's got 4 kind of input terminals which control which playback mechanism you want, and then you trigger it with an input. And so I can trigger that just by connecting that input to positive. So touch that pin there, and it's just applying a positive pulse to the trigger pin, and that will then play whatever sound file is queued up, or whatever's done by default. So that's possibly just zeros and all the inputs, and that's the first one that's there. So that's quite an interesting little device. It's one of those things that you could potentially strip out and reuse if you really wanted to, or even modify it in circuit to play a different kind of sound file. So that's this board. I'm not sure if I'm going to put it back together, but I don't know if it'll ever really get used, to be honest. I haven't come across or have had any devices which use this Powermat standard. Apparently it has been installed across on various different outlets across a couple of car manufacturers, so it's had some traction, and there probably are a range of devices out there which use this. Whether one will cross my path, that remains to be seen. Before I finish up, I just want to take a quick look at the receiver side of things. These are all kind of very small service amount parts, so there's not much that's identifiable on here. And so I'm just going to be able to get a vague kind of picture of what's going on here. These are probably the 2 kind of standout components and kind of partially identifiable. This is another Freescale IC, and it is most likely to do with the identification of the device. And so in addition to kind of receiving and smoothing out power, it's got to then communicate back, and that's probably there to... So when this gets power, it then starts communicating out what it is, just like an RFID tag. When it gets powered up, it then modulates the signal going out. I think that's what's going on here. So most of these components over here are probably just to do with the incoming power and power management, kind of diodes to kind of start smoothing out and rectifying the signal, capacitors maybe some kind of switching in and out to regulate the voltage before it finally gets outputted. The part over here is a dual MOSFET package, and it's connected directly to the input lines here. This is one of the MOSFETs in here, it's connected across here. So I'd expect that this is then coupled back to here in order to, the IC here uses this MOSFET to modulate the output signal, or to modulate that incoming signal, which the transmitter then picks up on. Sadly, this part is it's got a Freescale logo on there and part of an ID, but it doesn't kind of cross-reference or anything that I can find, unfortunately. And I think that's pretty much it for identifiable parts on this board.